Hi, in this video we will simulate a simple Manet scenario that runs DSR, Dynamic Source Routing algorithm, and understand the working of the protocol by looking through the packet animation and the packet trace features. Manet, which stands for Mobile Ad Hoc Networks, is a kind of network that usually has a routable networking environment on top of a link layer ad hoc network. Each device in a Manet is free to move independently in any direction and will therefore change its position and its links to other devices frequently. DSR, that is Dynamic Source Routing, is a routing protocol for Manets. It forms a route on demand when a transmitting computer requests one. DSR protocol uses source routing instead of relying on routing tables at each intermediate device. We start by navigating to create a new Manet project. A grid-based environment is displayed on the screen. We add 3 nodes, node 1, node 2 and node 3 in a manner such that node 1 and node 2 are close to each other while node 3 is far from node 1 when compared to node 2. This is done so that packets that are sent from node 1 to node 3 are sent via node 2 and not directly from node 1 to node 3. Right click on node 1, set destination as node 3 and enable a voice application. Select the routing protocol as DSR in the network layer section. Note that Manet operates in a wireless environment and hence path loss occurs. Right click on the environment and click properties. Set the path loss exponent relatively high, for example 3.5, and fading figure and standard deviation values are set as 0 so that node 1 may not directly communicate with node 3. After this, click on packet trace icon in the trace menu and give the file name its type. In this case we choose CSV, that is comma separated value, and the file location. Also do ensure that all the attributes are checked for a better and detailed description. Then we click on the simulate button, which opens a menu where we enter the simulation time as 50 seconds, the experiment name, then we enable record animation and leave the seed values at their default values. We then execute the simulation. After the simulation is complete, click on the View Packet Animation link on the left hand side and a window opens showing the network along with playback controls and a slider to control the animation speed. Users who are new to NetSim can slow down the slider to a comfortable setting to understand the transfer of packets more easily. The grid shows the wireless node as placed by the user during the start of simulation. Now let us study the simulation in detail with the help of the packet animator. It proceeds in the following manner. Node 1 sends a DSR RREQ route request to node 2, which also sends the same request to node 3. Node 3 in turn sends an ARP request to node 2 to resolve the address on the network, and node 2 in turn replies to node 3 with the ARP reply. Node 3 then sends a WLAN ACK to node 2, acknowledging that it had successfully received the ARP reply. Now DSR RREP, which is the route reply, goes from node 3 to node 1 via node 2. Node 2 sends a WLAN ACK to node 3, indicating that it has received the route reply from node 3. Now node 2 sends an ARP request to node 1 and node 3. Node 1 returns an ARP reply to acknowledge, for which node 2 sends a WLAN ACK to node 1. After this, node 2 sends the DSR RREP to node 1 and node 1 sends the WLAN ACK to acknowledge. Hence, after this step, node 1 knows the route to node 3. Now the transmission of a voice packet takes place, which is shown as a green line in the animation. Since node 1 knows the route to node 3, it sends a voice packet, voice 1, to node 2 and node 2 replies with a WLAN ACK. Before node 2 can send this to node 3, node 1 sends another voice packet to node 2 shown as voice 2. Again, node 2 replies and sends a WLAN ACK acknowledging that it had received the voice packet from node 1. Next, node 2 sends voice 1 and voice 2 to node 3 and receives WLAN ACKs from node 3. Now the DSR ACK for voice 1 goes from node 2 to node 1, to which node 1 responds with a WLAN ACK. Again, node 2 sends the DSR ACK for voice 2 back to node 1. This completes one successful transmission of a voice packet from node 1 to node 3. Let us look through the same via the packet trace. If you open the trace file, you will be able to see the top row showing parameters like packet ID, segment ID, packet type, control packet type, source ID, destination ID, transmitter ID, receiver ID, and many more. In this video, we will just stick to the 4th, 5th, 6th, 7th, and 8th columns to get a basic understanding of the packet transfer mechanism. Now let us look at the trace file generated by the earlier simulation. The second row shows a packet of type DSR RREQ being broadcasted. You can see broadcast in the destination ID field by node 1 under source ID, with receiver being node 3 under receiver ID. The third row shows the same procedure. The fourth entry also shows the same broadcast signal being sent from node 1, since the second attempt must have expired. In the 5th and 6th row, node 1 again sends the DSR RREQ packet to node 3 and node 2 because of error. In the 7th row, we can see that the signal broadcast 0 being transmitted from node 2 to node 1. The 8th row shows that the broadcast 0 signal by node 1 is sent to node 3 through node 2. Now in the next step, that is the 10th step, we see an ARP request, which is a request for address resolution being sent from node 3 to node 2. The 11th row shows node 2 replying to node 3 with an ARP reply control packet confirming the request. After that, node 3 sends a WLAN ACK signal to node 2 in the 12th row, acknowledging that it had received the reply which was sent to it previously. The 13th row shows that node 3 sends a DSR reply to node 1, which goes to node 2 since it can't be sent directly. Consequently, node 2 sends a WLAN ACK to node 3, as we can see in the 14th entry. In the 15th and 16th steps, we see the ARP request packet being sent by node 2 to node 1 and node 3. In the next step, node 1 sends ARP reply packet to node 2. In the 18th step, we can see node 2 sending a WLAN ACK to node 1 for the ARP reply which it received. In the 19th step, we can see the DSR reply packet sent by node 3 to node 2, finally reaching node 1 via node 2. In the 20th row, node 1 sends WLAN ACK to node 2, acknowledging the reply it received in the last step. The 21st row shows the first voice signal sent from node 1 to node 3. But since the signal cannot be transmitted directly, it is sent to node 2, which is the receiver ID, which will push the packet then into node 3. In the 22nd step, node 2 acknowledges node 1 with a WLAN ACK. After the acknowledgement, node 1 again sends a voice signal to node 2 in the 23rd step, to which node 2 again replies with a WLAN ACK in the 24th step. This step marks the transmission of a voice signal from node 1 to node 3 because the voice signal previously sent by node 1 to node 2 has reached its destination, which is node 3 in the 25th step. And next, node 3 acknowledges and replies to node 2 with a WLAN ACK in the 26th entry. Hope this gave you an insight into the packet animation and packet trace features of NetSim.